All right. Well, anyways, I just want to reiterate why everybody's here today. Thank you for coming out. So this is the real world of Badgelife. So I'll go ahead and load up my slides. And oh yeah, one thing real quickly before I proceed. I'm on Tether. The wireless here is not working. So anybody has a trick for that? That'd be excellent. No tricks for the Wi-Fi?
Yeah, do you want to mind us to find out the Wi-Fi?
It's all kind of getting into the school network. It's okay, just give me a second while I fix a couple of my interactive web-enabled slides. Okay, I think I got them all set. All right. I'll do it on top. And make sure sound works. It's sound on this. Yeah. Okay, so it'll work.
I feel like I'm at Comp 18.
Yeah. This early?
Do you remember? we're trying to get the pod set up.
Oh. All right. So welcome to the real world of Badgelife. It is not all sexy circuit boards and fun projects and all kinds of stuff. There's actually a lot of things to it. So today's talk is about what it means to be a maker. And you know, there's stuff like Maker Faire, right, where you build things out of wood and metal and fabricate. Well, this is a badge maker. This is circuit boards and research in China and designing and all kinds of fun stuff. So, welcome. Thank you for coming out today on your weekends. I hope you enjoy today's presentation. You learned something new. You have some fun with it. We'll start out with a brief agenda of who am I, and then we'll talk about hashtag Badgelife a little bit. Where the heck that came from, a little bit of history of the concept of wearing a circuit board and why it's actually pretty cool. We'll get into stuff like the software, the circuit board making process, the companies behind that. My favorite, supply chain. China, supply chain China. And I emphasize China. And
Hashtag cheap labor.
Hashtag everything's cheap. It's the source of everything today. Nothing is really made in America anymore, which is sad. And then questions, and then we'll do some hands-on stuff. So that whole table is just a couple of the things sitting in my little home lab. And it may seem like a lot to some of you, but this is the life that you live when you're a badge maker. So, anyways, that's a rundown for today. So let's talk about who am I? I have a Master's of the Cybers from USF. I did my undergrad at UCF, Go Knights, who I affiliate with. I'm a DefCon security goon, so if you're out at DefCon, you'll see me. I work in SOC team, wear a red shirt, and I yell really loud. So, along with Sunny, Charlie, Nestor, we're co-leaders of the Lost Tampa chapter here, so please come out and see our events if you haven't already. A lot of familiar faces, so we'd love to see you. Besides Orlando co-founders, we just celebrated our 7th year. For all of you that came out there, and the badge is over there. I do Splunk for Guide Point Security. If you have Splunk questions, you can ask me those too. Rich, why do we talk about Splunk so much?
I don't know.
Because it's always breaking.
Because it's always fucking broken.
Well, I fix it. So, I got a couple Sancerts, things and stuff, you know, those letters after your name. You can look me up on LinkedIn and see all my letters. And I'm a soon-to-be husband. Excited about that. You can too have hobbies and get married.
Sometimes.
Sometimes. All right, so let's just jump right in, right? Badgelife, it's awesome. This is the table shot of the super secret Badgelife meetup that took place 2 years ago at DefCon, so DefCon813. And this was just this was the first kind of informal get-together. DefCon let us use a room that was empty, and all the badge makers had an internal secret communication system. And we all said, meet up at this one place at this one time, and come and hang out, and we'll trade, and we'll talk. And so if you look across this table, some of those items are out there. I separated the section on the left to be the DefCon 25, and then the section on the right to be DefCon 26. And so there's my little alligator in this vast spread of excellence and talent. And if you notice, not everything exactly is a circuit board. The concept of having a cool badge to represent your crew or where you're from or what group you roll with. There is a leather biker jacket for Telefreaks. That was their badge of honor for that year, right? This is a little tribble. The circuit board was inside this big fuzzy thing and it lit up. It's super cool. As you see, there's shapes or sizes. The Tiki Man is actually 3D printed on top of a circuit board, so it's multiple creatively built components assembled together, right? And then there's all the rest of the designs and the artwork. We have this one over here, which I have on the table. It's just acrylic laser cut, but it's a deodorant holder because 3-2-1. And for those that are not familiar, 3 hours of sleep, 2 meals a day, and 1 shower. And always wear deodorant. That's which I recently learned there's a big difference between deodorant and antiperspirant chemically, but that's a whole other story. But anyways, and then it's not just the badges too. As you see, there's custom lanyards that are being made for this. You can go out and get them custom stitched and all the design. And then you see there's little boards throughout. These little boards are little trinkets, little toys. So many things can be made out of circuit boards, like poker chips. I got a couple down there from different groups. There's a little Tindy dog.
What are they called?
Huh?
What are they called?
What?
The little ones.
Well, we're not there yet.
The add-ons.
So this is before that. This is before the advent of the add-on. These were just kind of little things. Like the Tindy dog, the blue one up in the middle, it's actually a pin that you wear. It has a little battery and it lights up on the eyes. It's super cool. So this was my first introduction to Badgelife, where I showed up and I had only talked to a couple of these people online, and it was just like, holy cow, this is awesome. You guys are amazing. Can I trade you? Like, I've got a bunch of alligator heads that have a Wi-Fi hacking challenge and are light controlled over, with an application running on the badge. What do you got? And so we traded, and it was a lot of fun, and that's how I acquired a lot of these things. So that was the first year, right? And then Badgelife grew! This was last year at DefCon in the super secret Badgelife location. And the reason I keep talking about secrecy is because there is an entire demand around Badgelife. But the concept of Badgelife is you have to be a maker to be a part of it. You can be a participant, but to be on this inner circle, you have to have proven yourself. You have to have created something. So Badgelife grew. It grew dramatically. Across this table, we have all kinds of stuff, and we're starting to see, groups, DC groups from all over the world. Villages are involved in Badgelife. So Crypto Privacy Village, Car Hack Village makes their own badges. The Crop Dust Village,
Crop Duster Village.
Soon to be Crop Duster Village, Mobile Village.
The first DefCon Mobile Village.
Yeah, you'll see it next year.
You'll see it this year.
Yeah, this year. And then this is also the first year of the add-on. And so these little circuit boards are add-on modules, like hats or prizes or status symbols of your badge. So your badge was intended to be built with them, and it's meant to kind of, add a little extra. QueerCon was the first group to actually build the first concept of an add-on. They developed the squid badge, and on top of it were 2 additional module plugs. And they had all different kinds of really cool designs for different rankings or status within the organization. And so one of the big ones was an Uber hat, and it was a hat for the badge. And that concept was very interesting. It was the idea of expanding your board with little fun little modules. And that grew into a lot of discussions with Badgelife, to the point that now we have add-on standards. The first standard was a 4-pin. This year it's going to be a 6-pin. It's all published online already. So we're all abiding by this new published documentation. And standards is really important. And I keep emphasizing that because we'll get into why you want to follow a standard across the board. So again, 2017 Badgelife, this is 2018 Badgelife. I have no idea what we're going to look like this year, but it's going to be many more people, many more boards, many more add-ons, and so much creativity. There's a lot of collaboration between the groups too. For instance, there's an entire Bluetooth network that's happening between these badges. If your badge has Bluetooth, you can opt to play in with the other Bluetooth badges, where when you're in proximity, something magical happens on your badge, showing a friendly gesture to that other community.
Or you can do a seance.
You can do a seance. That was wired though; it wasn't Bluetooth.
Well, I know,
But for instance, so crypto privacy has Bluetooth, and the vendors have Bluetooth. And so, for instance, when a vendor was in range of a crypto privacy, it would immediately show up the Crypto Privacy Village logo on their screen, kind of like an homage or a hey, how's it going? Little gesture between the different organizations. It's really become very cool.
State Farm was BLE as well.
State Farm was BLE, and there's a lot of community behind this. So, all right, it has grown so much that there is a damn documentary, which if I had, oh, it does work. Oh, wow, look at that. Can I press play? Oh, can you?
You try
You have to come out and go back in to load it.
You have to go out and come back in?
Sometimes you do it with the PowerPoint. It doesn't go right from the beginning.
You got the career kind of VIP.
Yeah. So we're at the point that Badgelife is taken off. It should play in the thing, right?
Yeah. Yeah. Kind of. There you go.
Okay. Right.
Hi, I'm Sophie.
Just a little bit there. It is
What a
really
teaser.
not- Does that work?
No, so you have to
Just a
come out
teaser.
and do everything and then go back in.
That's really
No, you don't.
stupid.
Right click, hide,
You're right.
show presenter.
Click there.
pledge.
You're good.
Oh, I guess I can do that. That'll work, actually. That's a good idea.
Hi, I'm Sophie Kravitz.
It's the gift that keeps on
Yeah.
giving.
Wow.
Let's go.
Yeah, there it is. Good call. Yeah, I just so anyways, this has become such a cultural phenomenon that they went out and made a movie on it. We're not going to watch the whole thing.
Showing here on
but-
Flex Room.
This is just one of our bling modes. It's when we go through our menu, we have like ones with patterns, ones with like animated GIFs that you would see online.
So you did a Kickstarter to fund this, right?
We did. We sold 300 in about 8 hours.
Yeah, I saw that. It was
Yeah,
like gone.
it was gone immediately.
Congratulations.
Yeah, thank you. The year before, we sold 100 in 12 hours. So the desire to buy these badges is just so high right now. We make things for fun, but we let a lot of the engineering bleed in where before we think of a quantity or what we want to do, we kind of just lay out what do we want it to do and down select our parts and try to put together, trying to map out block diagrams and everything what we want, but
But you get the idea, and you guys can go home and watch this on your own time. It's about 13 minutes. It's not too bad, but a couple of the big badge communities and
Okay,
badge
wait.
makers are part of it, right? For instance,
Oh, well.
Brian Benshaw.
The idea from this came, I think it was 2 DefCons ago, when I was in Paris, when DefCon was over in Paris. I saw the QueerCon Squid badge, which had the clear solder mask, and I saw the Andexor guys doing their independent badges, and I saw a ton of Mr. Robot stuff because some of the DefCon higher-ups are consultants on the shows. So basically those 3 ideas just went into my mind, and I came up with this.
So hopefully that shows it doesn't take a lot to really start your project. It just takes a little bit of inspiration, a little bit of creativity, and a really fun idea. So that's kind of where I come up with different things. So a little bit of my repertoire, how did I end up in Badgelife? Is I built my first badge for our first B-Sides Orlando 7 years ago, which was, hey, they do this at DefCon. I can do it too, right? Like, those nerds aren't smarter than me. Turns out they're very smart. And because it's very difficult. And so 2013, yeah, that was quite a bit ago. And so I've been like learning and hunting down the process. So the one on the top right, the one with the B-Sides logo, was my first badge. I kind of went all out and put like a full LCD screen on it. It was programmable, it was hackable, it was open source, it was crazy. I had no idea the extent of where I'd be today I just thought like this would be a really fun project, and I didn't even do it the next following years because it was just so exhausting and so difficult, very expensive to put this stuff together if you're just getting into it, if you don't know all the little tricks and the secrets yet. So I was getting things done domestically, stateside, parts and shipping, and it was just, it was absolutely nuts. But at the end of the day, we had all the boards. We had a soldering party the night before where we assembled them, and the attendees loved it. And there are YouTube videos of people hacking the badge and doing other things with it and showing really cool, unique projects with this. So you can look those up. And then in 2017, I jumped back in and I was like, it's been a while, I haven't done a project, and that's where the first Florida Man badge came from, which is the Gator head. It was an embedded circuit based off of what's called an ESP8266, which sounds fancy, but all it really is an Arduino with Wi-Fi, if anybody's familiar with that. And so with Wi-Fi, you can run an entire web server on the badge, which I did. And it had pretty lights, which are perfect. Everybody likes blinky lights. And this took, I mean, the first badge, it took me probably about 8 months to figure out how to do and build up and get it working. The Gator probably took closer to about 6 months. Since it had been so long, I really wanted to set out on that challenging end, and I felt like I had learned a lot in the process. And then in 2018, we did the B-Sides Orlando one, which is the bottom left, Permit Technologic. Heather's our awesome artist, and I did like a marquee, showing marquee if anybody was out at B-Sides and has that. In 2018, we also did our second revision of the Florida Man badge, which is the alcoholic conch shell, which you all just saw demonstrated. Again, it's just inspirations of ideas, right? What is Florida about? What does it mean to be from Florida? Well, conch shells are cool, and I wanted it to be like a horn that you blew into, but then what else do we blow into the state of Florida? Breathalyzers, because that's what we do here. And so that kind of dream combination came together with a little bit of artwork, badge. Lots of Googling, lots of understanding how breathalyzers actually work from a technology level, what's the science behind it, how do you collect that data, how do you present that data. You know, it's just lots of research. And we'll talk about how we even begin that process. And then if anybody attended the B-Sides Orlando 2019 this year, it's the top left one. That's Deviant holding his badge. He actually made his own badge this year, which was awesome. Because he's usually swamped with people asking him questions. But I have the red one there from staff, if anybody would like to see that. It was very basic, but the idea is that it was supposed to be a fun little project, and it's supposed to be a building thing for people to learn and get some exposure to this. And the coming soon Florida Man badge, I have some prototypes over there. I look forward to it. It'll be an entire weather station on your badge.
Awesome.
So, which means after the conference is over, you can actually use it at home and collect the data with it. I try to make badges that are functional outside of the conference. I don't want it to be like some of the other ones that are you hang it up on the wall and that's really pretty much it. I like you to be able to take it apart and reuse the modules and reuse the pieces on it and the components for other purposes, or just use the breathalyzer year round. So,
am I good?
Yeah.
No.
Fix that. So it's the best thing ever when you're like at Black Hat and you got your little conch shell on your neck. Somebody's like, oh, what's this? And I'm just go, here, watch this. And I think you do too, and it goes up and goes, oh, you've been drinking clearly. But it's better when you get like a C-level executive. So anyways, that's a little bit of the history of my badge life, construction and building. Like I said, it really just kind of set out on a challenge of, I saw this, I thought it was cool. I can figure this out, right? You gotta have that mentality of it's gonna be hard, it's gonna be difficult, there's gonna be roadblocks. Not everybody is gonna be very helpful, so you gotta really just take on this challenge on your own and be willing to spend a lot of money, a lot of sleepless nights. You have to understand that China is a 12-hour difference from us, so I'm up at 3 a.m. having a casual conversation with my manufacturer. I have nightmares. I get up in the middle of the night at 3 and I'm like, I need to go talk to China. They're actually required to speak English at the manufacturing process. Yeah. Hold on, sorry. Anyways, so that's a little bit about where I came from with this project and some of my artwork and the progression of it, right? The first one was very square. I had no idea that you can do shapes. And then it grew to a square with rounded edges. Sweet, I can make it not sharp on the corners anymore. To, oh my gosh, you can do really abstract creative shapes and colors, right? It's not just green, right? Circuit board can be a variety of colors. So it was just a long process of learning, always learning. And I'm still learning to this day, right? Never stop learning, especially when it comes to this stuff. And questions are always welcome.
Do you ever get to use like CAD or anything like that?
We're going to be talking a lot about that, the process that leads to this. Because, yes, that's a huge part. If it wasn't for the CAD, which is computer-aided drafting software, similar to like AutoCAD, right, which we build houses and buildings with, there is CAD for circuits. So, all right, continue through. So let's talk about the history of where wearing a circuit board on your neck actually became cool. In 2006, at DefCon813, Joe Grand was already building hardware. He'd been building hardware for a long time, since he was very little. If anybody was around during the radio scene and the ham scene, or was in comms in the military, you got exposed to hardware. You got exposed to circuitry. Joe Grand, and like myself, I kind of look up to this guy. I was soldering when I was like 10 years old. I was very lucky to have a family member who was into radio and stuff like that, and building your own circuits. I remember building the 2600 tone generator when I was very little because I wanted to. He was like, okay, let's put it together.
You wanted free phone calls, dude.
Well, this was after they stopped it, but it was more of like a historical moment, right?
Yeah,
I had
you had
2600
to.
magazine, I had the schematics. Who can help me build this thing? I thought it was so cool. And so I had some help from my uncle, and he taught me a lot about soldering, and I kind of just stuck with it. So Joe Grand, has been building hardware for a long time, and he thought that hardware was cool. There was a point in DEF CON where hardware was around, but people were still very focused on software and code. And so he taught a class at Black Hat, and it was a hardware hacking class, and it had such a huge success that Jeff Moss himself said, hey, Joe, let's talk about what you're doing here. I actually think this is very cool, and we might be onto something. Can you collaborate with me in DEF CON, and we'll build a project? And so Joe Grand released his first badge with DEF CON, and DEF CON's first digital or electronic badge is just the one in the top left, the smiley face with the eyes. And it was a very basic circuit. It had a button on the back. You press the button, and it had a couple different pre-programmed patterns, and that was it. It was really, really just pretty simple, but it was a huge success. And they held a badge hacking competition where it may seem basic, but what is the craziest thing you can build with this? What can you expand on it? And somebody made an entire synthesizer based off of the random occurrence of the LED lighting in one of the modes. One of the modes was solid, one of the modes was blink, and one of the modes was random. And they hooked it up to a synthesizer and made music with the randomness that was generated from the badge. And it just sparked this entire idea of these aren't just standalone toys. We can build stuff with it. We can expand on it. So Joe Grant continued to make DEF CON 14, 15, 16, 17, and 18 until he retired at DEF CON 18 and passed it on to Lost Boy. Lost Boy was the creator of most of the crypto challenges at DEF CON for many years that actually won you a black badge. Sometimes the challenges ran for 2 years in a row. Very grand challenges. He's a puzzle maker, and so Lost went on to create the badges and get him involved in his puzzles in this process until DEF CON 2016 when he retired and passed it on last year to the toy makers. And that is the current badge that everybody probably saw here at DEF CON. Very tall, 4 AA's, it had a little character that was jumping around the level. There's one of them over there. And so Toy Makers is the current community that's making the badges. And this is starting to feel a lot like the CTF at DEF CON, where every couple of years a community sets out on a very big challenge, a very expensive challenge, to bring something to the masses at DEF CON, and they have fun with it for a couple years, and then they pass on the torch and give somebody else a chance to really do something with this. So The official Badgelife community, hashtag Badgelife, was created by WBM. Her real name is Whitney, and that was founded in 2016. And I made it to that first event and met everybody, and I said, this is my work. This is things that I've created. Can I be a part of you, right? Isn't that one of the prerequisites? Somebody has to refer you, and you have to have proven yourself. And so Whitney's been really awesome as far as bringing the community together. And again, we have secret communication channels and secret things, but it's for good reason, right? We don't want to release stuff early to the public, right? We share projects and we share resources, but we want to keep that hype real.
Intellectual property.
Well, a lot of this is really just a hobby. This is
Oh,
fun.
yeah.
I wouldn't say anybody particularly does it for a living. We
cool.
do it on our spare time, our weekends, and our late nights, things like that. And today, thanks to Joe Grand's crazy idea many years ago, it is very standard almost to have a digital badge at a hacker conference, or at least a PCB of some sort, because PCB art in itself is becoming very big. As you can see, you can get creative with different color palettes. It's not just restricted to the color of the board and the color of the ink. There's different tones and levels and contours that you can actually do with it. So, in fact, the Mr. Robot badge is one of the first of its kind. It has 2 different color silk screens, which most board houses won't even make for you. And he was able to get them to agree to make a dual color circuit board, which is the only one out there on my table that actually has 2 silkscreen colors. I didn't even know it was possible. Apparently, if you like them enough or bribe them enough, they will do anything for money. So, anyways, it is very common to see them now around the world at HackerCons, as far as like CCC has stuff out in Germany, and B-sides all over the world have digital badges, as far as South Africa, and it's really cool what's going on with this. So again, if you have questions anytime, if you have comments, just scream them out. We're going to be here for a while, so I'd love to educate you as much as possible. Is it hot in here, or is it just me?
Vegetate you.
Can we figure out how to mess with that?
I can do that.
All right, so let's continue. No, we had a question earlier about CAD. So software, this is a big part of the process. And I will share these slides. I'll make them available just for everybody so you know. But the software I'm learning, again, always learning, and trying to figure out right now is KiCad. KiCad has been around for over 20 years. It's free, it's open source. And it is what we call an electronic design automation software, an EDA. Okay? And then Fritzing is another open source one, more in the amateur and hobby range. And that is, again, it's a CAD software, computer-aided drafting software, meant to make it. Something interesting about Fritzing is it has a virtual, what we call breadboard. I'll get into that, but you can actually visualize what your testing prototype in the real world looks like in the software, and then convert it to a circuit board. It's a really cool feature. Easy EDA is one that's entirely web-driven. It's all online. You don't even have to download anything. So you can now design circuit boards in the cloud without worrying about software, without worrying about versioning or compatibility. And then finally, one of the most popular tools out there is called Eagle. Eagle used to be cool in my opinion, but they got bought out by Autodesk, it's AutoCAD, and they turned it into a really expensive subscription model. So screw them. But it is the oldest of the bunch. It's been around since '88, so it's from the MS-DOS days. Right? Designing circuit boards in MS-DOS. Who knew? But it's a thing, and but it is most widely adopted. There are other tools out there, stuff like Altium is another big one too that's used in the professional space. So people that design circuit boards for manufacturing are going to use Eagle, if not higher level of software, but that's not really something the average consumer can get their hands on. It generally starts at about $1,000 just for the license. So I stick to the free stuff. KiCad right now seems to be the #1 adopted software. They're so big they even have their own conference. So KiCon is really cool. I believe it's in Chicago this year. Fritzing recently fell off their development chain, sadly, because it was actually my favorite for a while. It's the first software that I learned how to develop on, but they haven't had any updates in a couple of years, so I really hope that the community behind it can maybe do some funding or something and get exactly what a capacitor looks like in schematic CAD software, in every piece of software around the world. So once you actually start to get familiarized with a couple of these symbols, and the software helps you along the way, it doesn't just kind of leave you hanging. It says, I'm a resistor, I'm a capacitor. You then start to realize, maybe I can put these together because it said, connect pin 2 to a resistor, connect pin 3 to an LED. Well, I go and I pull a resistor from the parts bin, and I pull a LED from the parts bin, and I connect it to an integrated circuit, and they have all the pin numbers. So it's actually not as intimidating as it seems. Now, simple ones are going to be easier to read. More complex, there's going to be more components. But the idea is this is standardized. This is something that you can research. This is something you learn to get familiar with. Then comes the layout. Oh no, another crazy challenge, right? If we thought schematics were difficult, imagine what it's like to connect all these. All right, 2 stickers. So the first person tells me what this is. Yeah, who said it? All right. So you saw the schematic for the Arduino. This is what we call the layout of the Arduino. There's one microchip right there, and there's one microchip right here. So these are how all the different traces are connected, all the pins, according to that schematic, which is our blueprint of what we need to build, right? Or we're not even a blueprint, it's the regulation or the expectation of how it's supposed to work. Then this layout is going to be our blueprint, where the pieces exist. And this is truly an art form. Because if you can imagine, you have to manually route every single one of these connections between them, following what's expected from that schematic. If the schematic says pin 2 goes to this resistor, you need to place your chip somewhere convenient, and you also need to place that resistor somewhere convenient. Those are on opposite sides of the board. You're going to be kind of running around, and you can't collide, right? If you collide, then those 2 circuits are now connected, and if they're sending completely different things, you're going to have a problem. Imagine if you have positive and negative accidentally collide. You're going to get a short. It's going to spark, it's going to light on fire, it's going to nut.
What about multi-layer boards?
Oh, what?
Multi-layer boards?
That's what we're getting to. So you'll notice that there's 2 different colors of traces here. Some are red and some are blue. Well, a board is 2-sided. It's a plane, right? So we can run traces on the back and we can run traces on the front so that we don't have a collision. And how do we transfer them from the front to the back? We can use one of the holes, which is actually pretty clever because those holes are plated from the top through to the bottom. So any contact on the top is actually connected to the contact on the bottom. Or we can use what's called a via, which is just a very specifically purposed hole that transfers the connection from the top to the bottom. So now we're starting to get really interesting here, where we're having to run a trace this way and run another this way, but we have to jump over it so we can go to the bottom side of the board, to the top side of the board. Maybe we'll be a little bit more creative and we'll say that all traces that go vertical are on the front and all traces that go horizontal are on the back, right? There's different ways of doing this. This is truly an art form. This is something that just comes with experience. Now, these pieces of software are getting smarter. They're helping us a little bit. There's something called an auto router. And the joke is you never trust the auto router. It's an algorithm to help determine all of those connections for you and lay them out automatically based off of your schematic. Logically, if your schematic says 2 things need to connect, then that implies that on your layout it also needs to connect. And so it'll try its best to route around things and jump and go up and down and move around to mathematically figure out the best way to do it. It's not always perfect, but if you're just starting out with this, see what our router comes up with. See what the software can determine for a good route. I generally do everything by hand, but this also takes several days just to do this part.
Those auto routers, is that built into like KiCad?
Absolutely. There's KiCad, Fritzing, Eagle, they all have the algorithms. Most of them are niche and unique to the software. But yes, they have it built in. Now, again, it's cool to see what it comes up with. But I would be very wary to rely on it. It will do a good job at making sure that there's no contact. that there's no connections that aren't supposed to be there. It just gets a little weird sometimes. It's not always creative. If you noticed how a lot of these lines kind of bunch together and there's pairs and there's almost like flow, like a waterfall. It'll do some of that, but I like a pretty layout because also when you're sitting there working with the real thing in hand, it's easy to kind of just see where everything goes. And it's not really just kind of every wire's on its own. And I like to do them in bunches, what we call buses. If anybody remembers like a parallel cable or something like that. The concept was that was 25 wires grouped together going to a destination. Well, you can bus together the components of the circuit board. It also just comes down to creative layout, right? If two pieces are meant to be connected, and you put them close to each other, right? You do it in clusters, right? This whole circuit over here is a voltage regulation circuit. You just put it up here near the voltage regulation stuff, right? If this is a power plug, then this is the voltage regulator. Don't put this component all the way on the other side of the board. So if you remember, in the circuit, in the schematic, we actually broke them out into sections. So this section is voltage regulation, this section is USB to serial, this section is the actual programmer, this section is, a different component. So you're putting them in sectors. Now, how do we know when we're building this to put all of these parts with this? And we'll get to that in a second. But the idea is you build them in pieces at a time. You don't just go all out in one big picture because then it's not organized. It's not easy to review. Or oftentimes you reuse parts of your project for other projects. So you can copy only a section and put it into your new one. So that's the layout. Now that we've designed our schematic, thanks to somebody on Google, and we've put it together in our CAD software, following all the rules of design, we send it off to our fabrication. There's a lot of steps that it takes to make a circuit board. It is not a very simple process. If anybody remembers back in the day of who used to make their own circuit boards using copper plate and acid wash, right? And the idea was you used those traces on the previous slide on the layout. You printed those out on transparency paper, like the stuff you use for an overhead, on a laser printer, and then you expose the copper or you transfer it off the transparency to the copper, and then you expose it to an acid wash, and everything that the toner sat on top of didn't get eaten away, and then everything that was exposed, the copper was eaten away with the acid. So you were essentially left with all of the traces between the points. This is the way we used to do it. Now, for $16 and 3 days of effort, you can have a board at your door, 10 copies of it, thanks to this China and manufacturing process. So a lot of steps. I'll highlight a couple really good ones. But initially, you take your board, and by the way, the software outputs like a file. So think of like when you create a Word document, you want to save it as a PDF, you just hit save as PDF. It converts it as such. Holes according to your design software, they'll go through and they'll do PTH, so through-hole plating. That's that process of allowing any drilled hole to transfer the connection from the front side to the back side. Right? We'll do the etching, which is where that acid wash is, where we put down a protective layer where all the circuit traces go, and we erase everything else that's copper. Right? We do automated inspection. We bring it down and we start cleaning the boards. Then we do our solder mask, which is that covering of any existing copper that you want to protect from short circuits or other damage. Then we do our legend, which is our silk screen. Think of it like a t-shirt. We're literally laying on the white or the black ink for graphics and indicators. All right, we do a little bit more drilling for any kind of mechanical holes that aren't supposed to transfer signal from the top to the bottom. Right, we profile it, so we clean the entire surface off and level it. And then finally we go through the testing phase, where according to your schematic and according to your designs, if pin 2 is supposed to connect to a resistor, we check it. We check another set, we check another net, we check another net, we check it. And so it's called a flying probe, and it tests connections between different points on your board that are expected to be connected, and then it tests ones that aren't supposed to be connected, just to make sure no fault accidentally happened. All right? Then we do a final surface finish. We make sure it looks good. We do a manual inspection, and then it's off to DHL to be flown over here in 24 hours. So, on YouTube, you can watch all of these wonderful steps. This is my favorite factory. We're not going to watch the whole thing, but this is one of the companies that I really like to use, and they put out this excellent video showing the process, and you can actually like see every step and they explain it. It's really cool. So he starts out with they receive your designs and they verify and